Chapter 6, Unit 2. First thing you need to know about these problems is I want you to always draw a picture. It is super important. We're going to learn how to use tables, and tables only give you the positive answers. They do not tell you whether your problem answer is negative, so only your picture can do that. We're going to be using the normal distribution, and when we talk about probabilities, all we're going to be doing is taking these percentages and converting them to a decimal. So for example, between the mean of 0 and the standard deviation of 1, which is a z-score of plus 1, there are 34.13% of people in that category from the mean to 1 standard deviation. Well, when we talk about probability, we're going to say P is equal to 0.3413. Basically, we're taking a percent, dividing it by 100 in order to get a probability. So here's an example. Suppose the population distribution of math SAT scores is normal with a mean of 500 and a standard deviation of 100. What is the probability of randomly selecting an individual from this population who has a math SAT score greater than 700? Or in other words, the probability that X is greater than 700. Step 1, I want you to draw a picture, put the table below it with the scores. So here's what it should look like. You do not have to label the percentages across the top. That's fine. Just draw the normal curve, put your table across the bottom. And then I want you to draw a line where X equals 700 would be located. Then I want you to find the z-score. In this case, you can just look at the table and tell that a score of 700 is a z-score of 2. You could also check your work by using the z-score equation. So you'd end up with 700 minus 500 over 100, which would again give you 2. Finally, you're going to determine what percent of scores are to the right of or greater than the line. So make sure you have this normal table with you somewhere when you do these problems so that you can see the percents. And in this case, you'll notice to the right of the line is 2.28% of the scores. And remember, when we convert it to a decimal, we divide by 100. So the decimal moves 2 places to the left. So this would be 0.0228. So one of the problems that people have in this class is they say 2% is 0.20. Well, that's 20%. So remember, you have to put that 0 in there. You have to move the decimal 2 to the left. All right, so now we're going to talk about this unit normal table. It's located in your book. I'm also going to post a copy of the table if you want to print it. It might be a little easier for you. So basically, this table has 4 columns, okay? And this table is going to list the proportions of the normal distributions for all the z-scores. So column A lists z-scores, and remember z-scores are always 2 decimals. If you draw a line at a particular z-score, remember the larger part of the curve is the body, and the smaller part of the curve is the tail. And the body side always includes a z-score of 0 or where the mean is located. So we'll talk more about that in a little bit. So let's look at column B. This tells you the proportion in the body. So if you look at the picture on the top right there, you'll see a distribution where they drew a line where a z-score is located. They shaded in the part on the left. And that's a body because it includes the mean, or it includes the z-score of 0 in it. So that's a body. It's the bigger part of the distribution, okay? So if I wanted to know the distribution in the body for that particular z-score, I would look up the z-score on the left side and I'd read across to column B to find the proportion in the body, okay? If I wanted to know the proportion in the tail, see the diagram on the far right in the middle, which shows you part C. The tail is the smaller part of the distribution. It does not include the mean. And so you can look in column C if you want to find the proportion in the tail. And then column D would give you the proportion between the mean and a z-score. Okay, so we'll use that for special problems. So let's look at an example of how to use this. So first off, I'm going to tell you to draw a line as z is equal to negative 0.25. What proportion is located in the body and what proportion is located in the tail? So step 1, you're going to draw the normal curve and you're going to draw a line at z equals negative 0.25. So there's your normal curve. And there's my blue line. I drew it at negative 0.25. It's just to the left of 0 because it's negative. And then I want to know what proportion is in the body and the tail. So step 2, I'm going to label which side. Which side of that line is the body and which side is the tail? Well, in this case, you'll notice the body includes 0, so the body is on the right and the tail is on the left. And this is problem specific, so each problem it could be on the opposite side. You have to draw the picture to figure that out. All right, the next part, you have to realize that the z-tables, they don't have any negative z-scores listed on them because the curve is symmetrical. So all the probabilities you get on this z-score table are equal to all the negative z-score probabilities as well. So for example, our problem says negative 0.25 for a z-score. Well, we just look in the table under positive 0.25. In order to find the percent in the body, we read across to column B. We find the proportion is 0.5987. And then to find the proportion in the tail, we look again at that same column where z is 0.25. We read across to the tail part, and we find the tail 0.4013. Okay? Just, you have to realize that a body and a tail for a certain z-score always add up to 1 because it's always 100% of the curve. Okay? So if you know the body, you could actually just subtract that body 0.5987 from 1, and you would get 0.4013, the part in the tail, if you didn't feel like looking it up in the table. All right, so this means that 59.87% of the distribution is in the body, 40.13% distribution is in the tail. And then if we wanted to look in column D to see how much is between the mean and the z-score for z-score 0.25, you could read off and it would tell you that about 9.87% of the distribution is between the mean and that z-score. One thing that you need to note is while z-scores can be positive and negative, and only the positives are shown on the chart, proportions are always positive. You are always going from 0% to 100%. There's no negative numbers there. Proportions are just the decimal part of the percentage. So proportions are always positive, remember that. So here's an example using probabilities, proportions, and z-scores. So example 1, what proportion of the normal distribution corresponds to z-score values greater than z equals 1? Or in other words, the way we write it in statistics is p parentheses z greater than 1, close parentheses. Step 1, you're going to draw the normal curve, and then you're going to draw a line at z equals 1.00. Step 3 is you're going to shade in the part of the normal curve that's greater than 1.00 because the problem asked us that find values greater than. So greater means to the right of the line. Less than always means left. They both start with the letter L. Greater than is always to the right. Label the shaded part as a body or a tail. In this case, it's a tail. It does not include 0 or the mean. If it included 0 or the mean, it would be a body. This is a tail. So then we're going to look on our chart, go down and find z equals 1.00 and read across to the tail column, column C, to find the proportion of scores. And your answer that you would find would be 0.1587. So this means 15.87% of the scores are greater than a z-score of 1. All right, here's example 2. For a normal distribution, what is the probability of selecting a z-score less than 1.5? So draw the normal curve and draw a line at z is equal to 1.5. This time we want less than, so we shade to the left of the line. And then we have to label the shaded part as a body or a tail. Well, the shaded part includes 0, includes the mean, so it is a body. So we're going to look in the table under the body column. So go down on your table and find z equals 1.5. Read across to column B, and there's your answer. You should find that the proportion of z-scores less than 1.5 is equal to 0.9932. So here's example 3. Find the proportion of a normal distribution corresponding to a z-score greater than 0.8. So you're going to draw the normal curve. You're going to draw a line at z equals 0.80. And then you're going to shade in the part of the normal curve that is greater than 0.80. So again, that's to the right. Label the part that you shaded as body or tail. In this case, it's a tail. It does not include 0. Step 4, you're going to look on your table and find 0.80 and read across into the tail column, which is column C, to find the proportion, and your answer would be 0.2119. So about 21% of the scores are greater than a z-score of 0.8. All right, now we're going to kind of use the tables backwards. We're going to find a z-score when we're given proportions. So example 1 on this is what z-score separates the top 10% from the remainder of the distribution. So because we don't know z-scores, you're going to draw a normal curve with no z-scores listed. The only z-score I would list would be 0 in the middle. You're going to draw a line at approximately the top 10%. So the way you do this is because it says top 10%, you put your pencil on the far right of the curve and you go to the left about 10% where you guess, and then you draw a line. If the problem had told you the bottom percentage, you would start with your pencil on the left side and draw from the bottom up. Okay, so all we know is that the middle is equal to 50% on a distribution. So, and you only want 10%, so don't go as far as the middle, just start on the right and go over what you think equals 10%. And then shade in the part of the normal curve that shows the top 10% of the curve. So in this case, it would be a tail. So label the shaded part as a body or a tail. Okay, so we're interested in the top 10%, which is a tail. What you need to know is that when you're given percent, you have to convert to decimal. Remember to divide by 100 or move the decimal 2 places to the left so you get 0.1000. So we're going to use the tables going backwards. You're going to look in the tail column, which is column C, and you're going to try to find a proportion that's closest to 0.1000. And once we find it, then we're going to read across to figure out what z-score that was. So the closest proportion you can find is 0.1003, and if you read across, this gives a z-score of 1.28. Now you have to remember, the table doesn't tell you if the z-score should be positive or negative. Only your picture will tell you that. In this case, the picture is to the right of 0. It's on the right side of the curve, so the answer will be positive. So a score of positive 1.28 separates the top 10% from the lowest 90%. Here's another example. For a normal distribution, what z-score values form the boundaries that separate the middle 60% of the distribution from the rest of the scores? All right, this is a little different. You're going to draw the normal curve again. You don't know z-scores. You're going to draw 2 lines, which would represent the approximate middle the middle 60% of the distribution. So what I always do in these problems is I split it in half. I draw a line down the very middle of the distribution, which would be where the mean is, and I turn it into 2 problems. So I put half of the distribution, 30%, on the left and half the distribution on the right. So I label problem 1 is the proportion between the mean and the 30% on the left, and problem 2 is the proportion between the mean and the 30% on the right of the mean. Okay, so 2 separate problems. So what you have to do first is remember 30% is equal to 0.3000. And because we're talking about the proportion between a mean and a z-score, we're going to look in column D. And we're going to find a proportion closest to this. Okay, and then we're going to read across and figure out what z-score that is. So the closest proportion I can find in column D is 0.2995. I read across, and this tells me that z is equal to 0.84. Okay, and remember the table doesn't tell you if z should be positive or negative. So in this case, for the proportion on the left of the mean, the z-score on the left would be negative 0.84. It's 30% of the population to the left of the mean. And in this particular problem, there's also 30% on the right side of the mean, so the z-score on the right side of the diagram would be positive 0.84. They're both 30%, the number's the same, your picture just has to tell you which sign goes where. So the z-scores of plus and minus 0.84 are what separate the middle 60% of a distribution. All right, learning check problem 1. Stop the video, see if you can figure this out. What's the probability of randomly selecting a z-score greater than z equals 0.25 from a normal distribution? So again, draw the curve, draw your line, and you want greater than, so color into the right. Decide that this is a tail, so your diagram should look very similar to mine. Next step, you're going to go to your table and you're going to find z equals 0.25 and you're going to read across to column C, the tail column, to find the proportion, and your answer should be 0.4013. Learning check problem 2. What z-score separates the top 90% from the remainder of the distribution? So you're going to draw the normal curve with no z-scores listed. You're going to draw a line at approximately the top 90%. And the way I figured this out, I put my pencil on the far right of the curve and I went left until I got what I thought was 90%. Remember, 50% is in the middle, so it's bigger than 50%. So I keep on moving the curve left. So that's the top 90%. I'm going to label my picture. And then I'm going to realize that this is a body because it does include the middle, which is a mean of 0, z-score of 0. So the middle is the body. So next, I'm going to go to my tables. Before I can do that, I have to turn 90% into a decimal, 0.9000. Then I'm going to look in the body column, column B, to find a proportion closest to 0.9000, and then read across to find the z-score. This will give you a z-score equal 1.28. However, remember the table doesn't tell you if z is positive or negative, only your picture will. In this case, the z-score that you're looking for is negative 1.28 because it is to the left of the middle of the distribution, to the left of the mean right there. It's always going to be negative if it's to the left. All right, learning check problem 3. In a normal distribution, what z-score value separates the lowest 20% from the highest 80%? You could work this problem in multiple ways. I choose to use the words that they say first in a problem. This is lowest 20%, so that's how I'm going to work this problem. So draw a normal curve, draw a line at approximately the lowest 20%. So remember, start on the left side of the graph because it's the lowest side and come up to about 20%. Okay, shade that part in and tell me if it's a body or a tail. In this case, you should have found a tail on the left side. So then change 20% into a decimal and look in the tail column to find the proportion closest to 0.2000 and read across to find the z-score. I found z-score of 0.84. And remember again, the picture doesn't tell you if it's z is positive or negative. Only the picture will tell you that. In this case, the answer is the z-score of negative 0.84 separates the lowest 20% from the highest 80%.